Welcome to the series of Relational Database Management System. Myself is Fatima Rafiq, Assistant Professor, Abeda Namdas Senior College, BCA Department. We have already started with the transaction management. We have covered the topic Introduction to Transaction, Transaction State, Transaction Properties, what is concurrency, what are the advantages and disadvantages of concurrency control mechanism, then what is schedule, what is type of schedule, what is serializability. Today we will be starting with the conflict serializable. This is one of the type in the conflict serializability. What is conflict equivalent? In the conflict equivalent, one can be transferred to another by swapping the non-conflicting operations. As we know that whenever there is a operation read and read, it will never create the conflicting operations. So these operations are non-conflicting operations. But when we consider the operations which when one of the instruction is write operation, at that time these are non-conflicting operations. Means the result produces by T1 and T2 means read and write, and the answer produced by write A and read A will be two different answers. Two schedules are said to be conflict equivalent if and only if they contain the same set of transactions, if each pair of conflict operations are ordered in the same way. So if it is satisfying these two conditions, it means that that particular schedule is conflict equivalent. Like for example here, schedule S2 is a serial schedule because in this all the operation of T1 are performed before starting any operation of T2. If you consider S2 this serial transaction, here transaction T1 is executing and after that sometime transaction T2 is getting executed. While in the schedule S1, here it is a non-serial transaction, means the part of transaction T1 is executed and the part of operation T2 is getting executed. So the schedule S1 can be transformed into the serial schedule by swapping the non-conflicting operation of S1. So if we are able to swap some operations and if we are able to getting the value or the result same as S2, so at that time we say that S1 and S2 is conflict equivalent. After swapping the non-conflicting operation, the schedule S1 is become when we have a non-conflicting operation. Then how many non-conflicting operations we can have? All the operations where the read and read instructions can be swapped. So we can say that these instructions are what? These are non-conflicting operations. So just we have swap the non-conflicting operations. So the transaction T1 become read A, write A, and read B, write B, and transaction T2 become read A, write A, and then read B, write B. Since S1 is the conflict serializable, if we are able to find the schedule like this, where S1 where the serial schedule and non-serial schedule will generate the same results, at the time we say that it is a conflict equivalent, and every conflict equivalent schedule is also conflict serializable. I think this is clear to you. Here this is a steps to check whether the schedule is conflict serializable or not. Follow the following steps to check whether the given non-serial schedule is conflict serializable or not. Step number 1, find the list of conflicting operations. We already know the conflicting operations are the operations where the write operation is involved in the set of transactions. Number 2, start creating a precedence graph by drawing one node for each transaction. If you have a transaction, just draw if you have a two transaction T1 and T2. So we need to make we need to start making the precedence graph, but just drawing the number of node for each transaction. Like in this case, I have T1 and T2, so I'll be making two nodes. Draw an edge from each conflicting pair if XIV and YJV form a conflicting pair, then draw an edge from TI to TJ. It ensures that TI gets executed before the TJ. So like example, if you have a read instruction and you have a write instruction. So what you can do, you can make an age from T1 to T2, because this is the conflicting pair. Read and write operations are conflicting operations. Step number 4, check if there is any cycle which is there in the graph. If there is no cycle found, then the schedule which we want to find is the conflict serializable. Otherwise it is not. Like for example, if it is producing the graph and the graph is containing a cycle, so at that time we say that it is not a conflict serializable. If there is no cycle present, we say that it is a conflict serializable. So this is a way we need to find the conflict serializability. The next topic is view serializable, and it is very simple. A schedule will be a view serializable if it is view equivalent to the serial schedule. If a schedule is conflict serializable, then it will be a view serializable. But if it is not a conflict serializable, and if it is having a blind write, so we will go for the view serializable. Blind write means a write operation without any read. So how to check whether the schedule is view equivalent or not? We are having a schedule S1 and S2 are said to be a view equivalent if they satisfy following condition. Initial read. An initial read of the schedule must be same. Suppose to schedule S1 and S2. In the schedule S1, if the transaction T1 is reading the data item A, then in S2 transaction T1 should also read the value of A. Like the sequence of reading should be same. Next is update read. If in the schedule S1, if Ti is reading A, which is updated by Tj, then in S2 also Ti should read the value of A after the updating of Tj. Then in above schedule, it is not a view equivalent, because S1, in S1 T3 is reading a value, and updated by T2 transaction, where in S2 T3 is reading a value from transaction T1. So it is getting generated two different value of read from two different transactions, two different set of transactions. And the final is a final write must be same between both the schedule. In the schedule S1, if the transaction T1 update A at last, then transaction in the schedule S2, the final write operation also has to be done by T1. In the above schedule is a view equal, because final write operation in S1 is done by T3, and in S2 the final write operation is also done by the transaction T3. So if any transaction is satisfying these three criteria, like initial read should be same, the sequence of read and write should be same, and the final write is also should be same, should be done by the same transaction. If these three things are these conditions are satisfied, we say that it is a view serializable schedule. So this is all about serializability. Here we ends with the chapter number 3, that is transaction management. If you find any difficulty regarding any point, you can write in the comment box. Thank you.